Alright, today we're going to finish up our geometric sequences and series section. And what I want to do today is just to find some missing information. So, some of you may find that we don't need to watch the video, which is fine. If you can remember your formulas and you can find the information that we're asking for. A couple of formulas that I do want to go over again for a geometric sequence. The sum of a geometric sequence is either the first term times 1 minus the common ratio to the n over 1 minus r, or if we know the last term, we know that the sum is going to be the first term minus that last term times the common ratio over 1 minus r. Not that we're going to need it in the notes here, but you may have an infinite series. These are both finite series. If we have an infinite series, then it's going to be a sub 1 over 1 minus r. Remember, our r has to be, the absolute value of r has to be less than 1 there in order to be able to use that infinite series and have a summation. So, if in example 1, we give you if we want to find the first term, given the 10th term is 500 and the common ratio is 2. Well, I want to find a sub 1. So which formula do we use? We know the sum of the first 10 numbers is going to be 500, so we know that the number of terms is 10, and we know the common ratio is 2. I'm looking for a sub 1, so my first formula there is going to work out pretty nicely in order to find that. So I know my 10th term, which is 500, is going to equal that first term times 1 minus r. Well, I know my r, my common ratio, is 2. I also know the number of terms, which was 10 over 1 minus 2. And now if I go ahead and solve that equation for a sub 1, I've found my answer. Well, what do we have? We have 500. Simplifying this, we have 1 minus 2 to the 10th. And I, myself, don't know what 2 to the 10th is, so I'm going to go and throw that in my calculator. And 1 minus 2 to the 10th gives us a negative 1,023. 1 minus 2, I do know that without a calculator, is negative 1. So I have 500 equals a sub 1 times 1,023. Go ahead and solve for a sub 1. I end up with 500 over 1,023. Now, if I were to take 500 and divide it by 1,023, it's going to be a very ugly, nasty decimal. So I'm just going to leave it as this fraction, 500 over 1023. Example 2, can we find n if s sub n equals 363? If we know the sequence of 3 plus 9, or the series 3 plus 9 plus 27, so on and so forth. Well, again, we don't know that last number. We don't know how many numbers there are. We do know the first term, and we do know the common ratio. It doesn't tell us up here in the given, but it does tell us here that our a sub 1, or our first term, is 3. So I know that s of n is going to equal 363, and s of n also equals that first term, which is 3 times 1 minus the common ratio. How do I get from 3 to 9 to 27? I multiply it by 3 to the n over 1 minus 3. Now I can go ahead and solve this equation. I can go and divide both sides by 3. So I get 121 equals 1 minus 3 to the n over negative 2. I multiply my negative 2 over. That gives me negative 242 equals 1 minus 3 to the n. Subtracting 1, I get negative 243 equals a negative 3 to the n. Divide by negative, I get 243 equals 3 to the n. Well, what do I know about 243? 243 is 3 to the 5th. And that's going to equal 3 to the n. So if my bases are the same, my exponents have to be the same as well. So 5 is going to equal n. And that's what we're looking for. One last one here. We have example 3. Again, we're given a common ratio of negative 2/10 or negative 1/5. We know the sum of the first 6 terms is 249.984. And we know the first term is 300. Can we find a of 6? And some of you may say, well, I can find a of 6 without knowing that sum. I can take 300 and multiply it by negative 1/5 6 times or 5 times and get my 6th term, which is completely fine with me. Others of you may want to use the formula. So with this formula, we can go ahead and find that as well. So in this case, we're looking for a of 6. That's where we'd use the second equation. Remember that second equation for the sum? If we know the first term and the last term is a sub 1 minus a sub n times r over 1 minus r. So we know the sum of the 6 terms is 249.984. We know the first term was 300. We don't know that last term, so a of 6 if you wish, times that ratio, which is negative 2/10 over 1 minus negative 2/10. Now we can go ahead and solve this equation to find our a sub 6. So clean this up a little bit. We have 300, a negative a sub 6 times a negative 2/10 is going to be a positive 2/10 a sub 6 over 1 minus a negative 2/10 is going to be a 1.2. So again, I'm going to pull my calculator out because I don't know. 249.984 times a 1.2. We multiply that 1.2 over 1 2/10. That gives us 299.9808 is going to equal 300 plus 2/10 a sub 6. I'm going to subtract that 300 over. So I get a negative 0.192, and that's going to equal 0.2 a sub 6, divide by my 0.2, my 2/10, and I get a negative 0.96 equals a sub 6. And that's going to give me my 6th term in this series. Happy geometric series.